higher order derivatives. Higher order derivatives. Higher order derivatives is the heading. Higher order derivatives. Right. Now, people will see this way. One example. I'm going to take the function y equals sine x. You know, when you differentiate this sine x, the first derivative of sine x with respect to x, it is now dy by dx, no? Derivative of sine x is cos x. So this is called as the people first derivative. Dy by dx is called as the first derivative. Now, this first derivative, right, I am going to differentiate again. I'm going to differentiate again. You know, when we need to differentiate something, people, the operator we have to apply on that is this. This is called as the differential operator, right? Operator. Differential operator. Right? Differential operator. So the function that should be differentiated is put where here. For example, if I put here sine x, then the meaning of this whole thing, differentiate sine x with respect to x. That's the meaning. So if I need to differentiate both sides of this equation with respect to x, then I must apply this differential operator to both sides like this. D upon dx, I should apply to this dy by dx. And on the right hand side also, for the cos x function, I must apply the same differential operator. So then, you know, when this is differentiated cos x, when we differentiate with respect to x, the answer is, people, minus sine x. Right? Now, this is the first derivative of y with respect to x. Now, that one we again differentiate with respect to x. Then people, we say we get the second derivative. We get the second derivative. The second derivative of y. It is written like this. This d and this d, we write as d squared y divided by dx squared. This is how we write the second derivative of y with respect to x. Right? So we don't write this 2, we are here. Then we get a certain misunderstanding that we are going to differentiate y squared. This d and this d we multiply, we get d squared. Dx and dx we multiply, we write dx squared here. The function we have already differentiated 2 times, we write usually here. This is called as, people, second derivative. Now suppose this one we are going to differentiate again with respect to x, right? So then again we have to apply to both sides the differential operator d upon dx. Once we apply that there, people, this is what we get. D over dx d2y upon dx2. On the right hand side, d upon dx minus sine x we must write here, people. Now the way of writing the left hand side is here d squared and this d cube. Dx and this dx squared is dx cube. So therefore third derivative we can write d3y upon dx3. It is, when you differentiate minus sine x, we can take this minus sign out because minus sign is a constant. We can write it like this, minus sign taken out. Sine x, when you differentiate with respect to x, we get cos x. Then third derivative we get as minus cos x. Like that, people, we can keep differentiating like this, and there we get the fourth derivative of y, fifth derivative of y, so on. We can find any derivative. So after the first derivative, the rest derivatives this way we obtained are called as, people, higher order derivatives. Understood? Higher order derivatives. So if I take as our right hand side function without taking like this sine x, this is a special function, no? To represent all the functions in x, if I write on the right hand side fx, right? Like this. Okay. Then the first derivative, we can write dy by dx is d upon dx fx. This is how we write that. Then the first derivative of this fx, people, we denote by the symbol f dash x. This is a standard notation to denote the first derivative of fx with respect to x. Secondly, when we differentiate this again, we have to write it like this, no? D upon dx, dy by dx, and here we must write d upon dx f dash x. Now, this one you know already, it is written as d2y upon dx2, right? Right hand side, this f dash x, when you differentiate with respect to x again, this is written as f double dash x, like this. Again, another once more, we can differentiate. Then here we get d3y upon dx3. Then it is equal to, this one we write as f triple dash x. Like that, we can symbolically represent these things. Okay, people? Right? So then we come to the first note and we'll come to some questions today, right? Yeah. Higher order derivatives, we can write like this. Write down, people, this way. Let y equals fx, where fx is a differentiable function in x, differentiable function in x, right? Then we can write dy by dx, it is d upon dx fx, right? This d upon dx fx on the people we denote as f dash x. This is called as the first derivative of fx, right? This is called as the first derivative of y. First derivative of y. This is called as the first derivative of fx. First derivative of fx. Right. Now this one we again differentiate. Differentiating again with respect to x. Right. Differentiating again. This is how we write in short form, differentiating again with respect to x. What? The first derivative we differentiate. dy by dx is f dash x, no? Then we apply the differential operator, d upon dx, dy by dx, d upon dx, f dash x. This is written as d2y upon dx2, and the right hand side is f double dash x. This is called as the second derivative. Second derivative of y. This is called as the second derivative of fx. Second derivative of fx. Right. Right. Another ones we differentiate this. Differentiating again with respect to x. d2 y upon dx2 we differentiate with respect to x. Then on the right hand side, d upon dx f double dash x. Left hand side, people, we write how? d3 y upon dx3, third derivative of y with respect to x. The right hand side, we write it by using the symbol f triple dash x, right? So this is the third derivative of y. Third derivative of y. This is the third derivative of fx. Third derivative of fx. Like that, people, fourth derivative, fifth derivative, and so on, we can write. Similarly, we can write d for y upon dx for f for x, like that. And so on, we can write. And so on, we get higher order derivatives. Here dx4, right? Right. Write down this, people. Right. People, now we shall come to some questions in the tutorial. In your tutorial, take your tutorial, page number 11, under question number 43. Page 11, question number 43. We'll start from its first question, second question. Right. 43 part 2. Given that y equals ae to the power mx plus be to the power minus mx. Here, this a, b, and this m are constants, remember. Usually, if we are not given there is a parameter or variable, except the letters x and y, the rest are considered as constants. Right? Unless otherwise given, people, we assume they are as constant. Right. So now in this case, we have to obtain this equation involving higher order derivatives. People, any equation involving higher order derivatives is called as differential equation. It's called as differential equation, right? Yeah. So now I am going to differentiate this first, right? So now differentiating with respect to x, we get for this y dy by dx. Then on the right hand side, when you differentiate, since this a is a constant, we have to keep this a as the same. E to the power mx when we differentiate, you know, people, e to the power something when you differentiate, first occasion, we get the same thing. That is because of e to the power something, after differentiating, we get the same thing, right? Then e to the power mx coming. Thereafter, we should multiply by the derivative of this mx. While m is a constant, derivative of mx is, how to differentiate mx, people? M is a constant, keep that m as the same, and multiply that by the derivative of x, it is 1. Right. And plus, this one now we have to differentiate. B is a constant, we have to keep b as the same. Now this e to the power minus mx, we have to differentiate. When you differentiate e to the power something, it is e to the power the same. Thereafter, that should be multiplied by derivative of this minus mx. Minus m is a constant, people. Keep that as the same. Derivative of x is going to be 1. Up to you, I think you can very clearly understand, right? So now here what we get is, people, dy by dx is equal to, you can write this m, right, people? This m and this m is common. Take that m out. Then open the bracket. Here we get a e mx. Plus and minus make minus b e minus mx. This way. Right. We found, people, the first derivative. Right. Now, the asking answer contains second derivative. It says, now once more, we have differentiate this. Right, people? Now you can write differentiating again with respect to x, right? People, now when you differentiate this first derivative, again we get second derivative. How to write that? d2 y over dx2. Right. Now the right hand side also we must differentiate. This m is a constant, we told. Then we have to keep m as the same, and opening a bracket, go into the bracket, and the two terms inside the bracket, now we have to differentiate. Now we'll consider this first. A e to the power mx. When you differentiate a e to the power mx, since a is a constant, keep that a here. E to the power mx, when you differentiate, we get e to the power mx. And we have to multiply that by the derivative of mx. Derivative of mx, as I explained here, m into 1, that is m. Now here, minus b, we have to keep as the same. Now we have to differentiate e to the power minus mx. That is e to the power minus mx multiplied by minus m, as I explained earlier, right? Minus m. Now, this is what we get within bracket. Right, now people will simplify this. Another m here and here, we have take that m out, then with this m, that is m squared. d2 y upon dx2 is equal to, once you take that as common factor out from the bracket, here we have a e mx, and this minus and this minus make plus. We have taken this m out, be minus mx plus minus and minus plus, no, plus be to the power minus mx. Right. People, you can very clearly see this one. This function is nothing but a e to the power mx plus b e to the power minus mx is the same thing. This, that is really y. So therefore, for this I can put y. Then we get the next result like this: d2y over dx2 is m squared y. People, now once you bring the right hand side m squared y to this left hand side, we get the answer asking as this way. Once you take this left hand side, people, this is 0. So this is how we get that answer. Right now? Okay. Right, people. Now we will come to the question number 43, part 3 as the next one. Question number 43, part 3. Question number 43, part 3. Right. Take that. Given y equals sine log x. There log x means people base you have to take of that logarithm as e. Then when the base of the logarithm is e, it is written as ln x, no? Better to write like this, y equals sine ln x. Right. Now you have to obtain this differential equation. Right. How to differentiate these people? First we differentiate with respect to x, dy by dx. First people, we have to differentiate this sign. While we differentiate this sign, we don't change any function inside that. We have learned that. That is coming under the theory of the function of a function, right? So then sine derivative is cos ln x coming. At a time, we differentiate only one function. The response after that, it contains, we have to keep as the same. Thereafter, we should multiply that by going inside the derivative of the function we meet. So ln x is the function we meet. Its derivative, you know, ln x derivative is people 1 upon x. So this is the first derivative. Furthermore, people, when we go inside x finds, now this should be multiplied by the derivative of x. Derivative of x is 1. I didn't write that one, people, because when you multiply this thing by 1, since it won't change. But if you have there any other thing, by the derivative of that, we must multiply that. Now, people, we need to differentiate this another once more, because the asking answer containing second derivative d2y over dx2. So that means we know this one we have differentiate another once more. People keep in like this when we differentiate both sides. The right hand side, this cos ln x is at the numerator. This x is at the denominator. When we differentiate the right hand side, there we have to consider the right hand side as a u upon v quotient form. People, we usually consider when we have quotient form to differentiate in developing this kind of differential equations. Usually we don't keep the quotient form to differentiate. Why? Rather than that, by using this way cross multiplication, people, we can eliminate the right hand side from what? Quotient form. If you do by eliminating this quotient form, the answer, the differential equation will be coming more easily. So therefore, as a practice, people, in developing this kind of differential equation, if you need to differentiate a quotient, a fraction, don't keep that way. By using the cross multiplication, remove that denominator, bring that denominator to the other side by cross multiplication. Thereafter, left hand side, now that x comes, you know, the left hand side will be u into v product form. A product form is much easier than people the quotient form. So therefore, always as a practice thing, when we need to differentiate a quotient, don't keep that quotient form. Bring that to by cross multiplication to product form and differentiate. That is much easier to obtain what that differential equation. So therefore, bring this x here, then what do you get? X times dy by dx is equal to cos ln x. Right. Now we have differentiate. They're asking, can we take this one x to the power minus 1 and differentiating as a product on the right hand side? That's correct. But rather than that, people, again there you use what uv form, no? Let's take that to left hand side. Still the left hand side we have uv form. Right. So now we have to differentiate this u and this is v. Now this is the product. U into v product, we differentiate, people, how? Keep this u as the same x. Now differentiate this. When you differentiate this, we get second derivative d2y over dx2 plus keep this dy by dx as the same. Derivative of this x is 1. You know, people, derivative of x with respect to x is 1. Then come to right hand side. First is cos minus sine. Derivative of cos is minus sine ln x. And now that should be multiplied by the derivative of ln x. It is 1 upon x. Now again, multiply this by x. When you multiply both sides by x, this x and the multiply x is x squared d2 y over dx2. Right, when we multiply this by x, we get x dy by dx is equal now on the right hand side, people, only this we have, no? Because this x will cancel off, no? By the multiplier. Sin ln x mean here, this, it is y. Put that y here. Now, once you bring this right hand side minus y to left hand side, we get this answer 2, no? Now, this will be plus 5, right? Write down therefore x squared d2y over dx2 plus x dy by dx plus y equals 0. This is how we take that differential equation. This kind of equation is called as, people, a differential equation, right? Yeah. Right, people, now we'll take 43 part 4 as the next one. 43 part 4. Right, take that one, 43 part 4. Given that y equals tan inverse x perfect squared. Ask him to prove x squared plus 1 perfect squared times d2y over dx2 plus 2x x squared plus 1 dy by dx equals 2. All right. People, I give you 2-3 minutes. Just try this question. People, now here, when you differentiate this, the left hand side we get the dy by dx first derivative. All right. When we differentiate the right hand side, we have differentiate from here. The power only first we, right, come across the fine. So then this part within bracket we have to just assume for a while as capital X. Then you have to think this as now x squared. We know how to differentiate x squared. The power 2 comes before x power new power 2 minus 1. That is how the power is differentiated. 2 times tan inverse x whole thing to the power 2 minus 1 means 1. But power 1 of something is the same. So therefore, no point of putting that power 1 here. Then I keep like this. Now, so far we have differentiated this power. Now that should be multiplied by the derivative of tan inverse x. People, derivative of tan inverse x is 1 over 1 plus x squared, right? 1 upon 1 plus x squared. So this is the first derivative. Thereafter, tan inverse only we differentiated like this. Thereafter, we have to multiply this also by the derivative of this, what, people, x. But derivative of x is 1. That is why we don't mention that one there, because when you multiply that by 1, the same answer is coming, no? Yeah, now in the answer, people, second derivative available. Therefore, we have to differentiate this another once more. For this, what I do is this 1 plus x squared we take to the right hand side as cross multiplication. Then 1 plus x squared into dy by dx we have is equal to 2 tan inverse x. Now the left hand side we have differentiate, people. This is your u function. This is your v function. Then the left hand side we have u into v. U into v. That you know how to differentiate. Keep this u function 1 plus x squared. That's the same, right? That should be multiplied by the derivative of this. Here we have first derivative. When you differentiate that, again we get second derivative d2y over dx2 plus keep this v, the dy by dx as the same. That should be multiplied by the derivative of this u function. U function contains first 1. It is a constant alone. Derivative is 0 plus x squared, derivative is 2x. Right, equals. Now come to the right hand side. right hand side, this 2 tan inverse x, 2 and this tan inverse x as a product. That occasion, you know the constant we have to keep as the same. Tan inverse x derivative is 1 over 1 plus x squared. Okay, right, people. Now, multiply again this both sides by 1 plus x squared. Multiply both sides by 1 plus x squared. Then what happens? This term, and this term, we have to multiply by this 1 plus x squared. Then here this 1 plus x squared term, when it is multiplied by itself, it will be 1 plus x squared perfect squared, right? 1 plus x squared to the power 2 come in, and this is second derivative d2y over dx2 plus, here once you multiply this by 1 plus x squared, we get 2x times 1 plus x squared, this dy by dx. And people, once you multiply the right hand side by this 1 plus x squared, that and this will cancel off. We get this 2. Once you bring that 2 to left hand side, that will be minus 2. Now on the right hand side, no value, 0 available. So this way, right, we have to take the answer, keeping the 2 on the right hand side. No need to take this to left hand side. This is also correct. But asking us is keeping the right hand side, this 2. This is the answer. Right, people. Now we'll take another one more, and thereafter we can another 2 more. We can go to the other part. Right. We'll take people. It's number 7. 43 part 7. Part 6, not 7. Part 6. Take 43 part 6. 43 part 6 take. Right. It is given there. Y equals ln. Log is given there. But remember, people, this time this log means ln to the base e. Ln x plus square root of x squared plus 1. Ln x plus square root of x squared plus 1. Prove that this sounds right. People take that. Take that, I'll give 2-3 minutes. Right, people? Yeah, who got the answer? Yeah, first we can differentiate this, right? dy by dx. First of all, we have differentiated this ln. Ln means log. While differentiating this log, the function inside that we don't change, right? So therefore, derivative of log means what, people? 1 divided by the function after log we have, that is this, no? 1 upon x plus square root of x squared plus 1. So far we have differentiated this. Secondly, this should be multiplied by the derivative of this. It contains 2 terms, right? First is x. When you differentiate x, derivative of x with respect to x, people, 1, right? Put 1 there. Now we have differentiate this. When you differentiate these, people, what is the method? First differentiate this root sign. Thereafter, it should be multiplied by the derivative of inside function. When we differentiate root sign, people, it is 1 over 2 times the same thing. Multiplied by what? Derivative of the function this. X squared derivative is 2x. 1 is the constant alone, 0. Then only 2x. Then this 2 and this you can cancel down. Right. Now we'll simplify this furthermore, people. Dy by dx is equal to 1 upon x plus square root of x squared plus 1 multiplied by, people, now this 1 has the denominator 1, no? Then I can take this root x squared plus 1 as common denominator there. What I am trying to tell you, people, this x squared plus 1 root, I am going to take as the common denominator. This 1 means 1 upon 1. Once you take this common denominator as this 1 should be multiplied by x squared plus 1. Understood? And people, now here we have x and this 1 means x. When you multiply them, we get x. Right. Now you can very clearly see this term x plus square root of this. The same term only, people, here we have. And then this 2 you can cancel down like this. Right? Now what is remaining now? It is now, people, dy by dx equals 1 upon this square root of x squared plus 1. Right? This is what we get now. Dy by dx is equal to 1 over square root of x squared plus 1. Right now? Now we need to differentiate this another once more. For this, what I do, we take this to left-hand side as a cross multiplication like this. This is equal to 1. Now you have to consider this as u, people, this as v. U into v we have. Now apply the derivative of that. Keep this u as the same. Root of x squared plus 1. Derivative of this is the second derivative. d2y over dx2. Right. Now keep this v as the same. Now that should be multiplied by the derivative of this. When you differentiate these, people, the root sign first we have to differentiate. What is that? Root sign, when you differentiate, 1 over 2 times the same root sign. Now that should be multiplied by the derivative of the expression inside root sign. X squared plus 1, x squared derivative is 2x plus 1, 1 is a constant alone 0. 2x plus 0, 2x, 1 change, no, that's all. Equals, on the right hand side we have a constant, it is alone, therefore the derivative is 0. Right, this is what we get. Now this 2 and this 2 you can cancel down. Now what I do to take this answer, people, we multiply both sides by the square root of x squared plus 1. We multiply this term by square root of x squared plus 1. Then what happens, people? The same term only here we have as the multiplier. When you multiply this by this, what happens? The root will eliminate and give in what? X squared plus 1 times d2y over dx2. When you use this to multiply this one we write here, no, that and this we can cancel down. dy by dx. And here we have x equals what? 0. This is how we take that answer. Right. Okay, people, the next important question in this case is 44. Right. Question number 44, page number 11 take. Right? Question number 44. It's a parametric differentiation. Parametric differentiation. Question number 44 is the next. Take the next question as number 44. Number 44. Right. Right. Take number 44. right? Right, it is this people. Given x equals sine t, y equals sine pt, asking to prove this differential equation. Right, x equals sine t, right, y equals sine pt. Now, in this case, we need to obtain this differential equation. Now, on the right hand side of x, we have t. Then what derivative we can find? Dx over dt we can find. Right hand side of this y, we have again t. Then we can find dy by dt. Here this p is a constant, remember, t is a parameter, right? P is a constant, t is a parameter. So then first I can differentiate this x, but with respect to t. Yeah, then what do we get? Dx upon dt equals sine. When you differentiate, people, we get cos t. Right, now here we can differentiate this y again with respect to t. The right hand side later only come into left hand side denominator. First sine derivative is cos pt, right? Now we have to go to this, and by its derivative, this should be multiplied by derivative of pt. P is a constant, like a real number 2, 3, like that. Then P and this T is as a product, no? Keep this P as the same. Derivative of T with respect to T, because we differentiate with respect to T, no? Derivative of T with respect to T is 1. P into 1, that is something but P. This is what people we get for our dx upon dt and dy by dt. Now, using these two, I can find with the help of the chain rule dy by dx. By chain rule, now you can write dy by dx. By chain rule, we can write dy by dx is equal to dy by dt multiplied by dt by dx, like this. We can write like this. You know the way of remembering this. When this dt and this dt cancel, dy by dx we get to right hand side. Similar thing available in the left hand side. Therefore, dy by dx is equal to dy by dt is this p cos pt multiplied by dt by dx. Dx by dt is this cos t, then its reciprocal only asking 1 over cos t. 1 over cos t. This is what we get for dy by dx. People, now the asking answer contains second derivative. That says we should differentiate this another once more. Once we keep like the same way, people, to the right hand side, we get u upon v quotient form. But we said usually we don't keep this quotient form to differentiate. We use that cross multiplication to convert that to product form and differentiate. Understand? So then use the cross multiplication by this cos t to this side. What do you get? Cos t times, right, this dy by dx is equal to p cos pt. P cos pt. Now, this time the left hand side we can differentiate, people. How? This is your u function, this is your v function, and now here we differentiate this left hand side and right hand side with respect to x. Suppose we are going to differentiate left and right both sides with respect to x. That means we are going to apply what differential operator? d upon dx operator only we are going to apply. Now we write that like this. Right? Write down differentiating both sides with respect to x. Differentiating both sides with respect to x. Then what do you get? D over dx. This is what people we have to apply. Okay, d over dx. Cos t dy by dx, no. Cos t times dy by dx. Right hand side, again, d over dx, p cos pt. Suppose we write this one. That says, people, to both sides we have applied the differential operator d upon dx to say to differentiate both sides with respect to x. Right. Now here you have u into v form, people. How to differentiate u into v form? Yeah, u into v form we can differentiate. First, keep this u as the same, right? Cos t, right? And differentiate this dy by dx with respect to x. Dy by dx with respect to x, when you differentiate, we get second derivative, no? d2 y over dx2. Now, keep this dy by dx as the same, and this cos t we have to differentiate with respect to x. Remember, people, d over dx, this is what we need now. We have to differentiate. This d stands for differentiate. Differentiate cos t. Here we have t, but asking to differentiate with respect to x. In order to differentiate with respect to x, people, here this letter should be x, but there we have t. Therefore, straight away, this cos t we can't differentiate with respect to x. Wait for a while. In the next step, I'll explain how to take that one. Now we go to right hand side. If p is a constant, we can take this p out. Again, the same issue come in. What, people? This function given in terms of t, but we need to differentiate with respect to x. If we differentiate with respect to x, this letter should definitely be x. Then that also, for a while, I write like that. D upon dx cos pt, like this. Understood? Okay? Now, people, I write cos t second derivative d2 y over dx2 plus dy by dx. People, now here for this place, I am going to apply chain rule. How to apply chain rule? D cos t, no? D cos t. I write here dt. But we have dx, right? Never mind. Take this dx here and write here dt. Then what happens? D cos t upon dx we must have. Now, when we cancel down this dt with this dt, d cos t upon dx only still we are having. We did like that, people. Now here we have t that we need to differentiate with respect to t. The letters this and this being the same. Therefore, cos t derivative with respect to t is minus sin t. We get the answer. Understood? Then this cos t function can be differentiated with respect to t. The same letters, no? That's why. For dt upon dx, we can substitute by this 1 upon cos t. For the right hand side also, people, we apply here what? Chain rule. D upon dt cos pt, right? And then dt upon dx. We get like this. Now this is differentiable. Here the letter t we have differentiate with respect to t. Now we come to the next derivative, right? Now, people, cos t here, d2y upon dx2 plus dy by dx. When you differentiate cos t with respect to t, that we can think like this. When you differentiate cos x with respect to x, the answer is minus sin x, no? Like that. Cos t when you differentiate with respect to t, minus sin t. Minus sin t. After differentiating this, we get minus sine t. dt over dx means people 1 over cos t. 1 over cos t. Now come to this equals p times, right? Cos pt when you differentiate with respect to t, cos derivative is minus sine pt first. Then that should be multiplied by the derivative of pt. Derivative of pt, since p is a constant, p. Then p times minus sine pt, minus sine pt, cos pt derivative is minus sine pt, pt derivative is p. And dt upon dx is people 1 over cos t. Up to here we got, right? Now what I do people next is I multiply both sides by cos t. I multiply both sides by cos t. That means this term, right hand side, this term we multiply by cos t. Then here already we have cos t, and this multiply cos t we have cos squared t, right? d2y over dx2. When I write cos t here, that cos t will cancel with this cos t. Plus and minus make minus sine t times dy by dx. People, now here p and this p squared, since we multiply by cos t, what happens? That multiply cos t and this cos t will cancel off, right? Now what do we have on the right hand side people? P and p squared. Before that we have minus sign, minus p squared sine pt. Bring that to left hand side, plus p squared sine pt. Once you take that left hand side people, right hand side, no value 0, right? Now we'll see how to take the next answer. Right, first come up to these people. I think you could understand this. Right. Now people, right, shall I write here? Okay, now this cos square t, I can write people as 1 minus sine square t. Cos square t, you know, we can write as 1 minus sine square t. d2y over dx2. Right. Now sine t. People, what is sine t? Sine t is x. Therefore, here minus x. Minus 6 dy by dx. Plus p squared. What is sine pt? Sine pt here is y equals 0. This sine t also, people, x naught, and this is x squared. Therefore, we get the final answer 1 minus x squared times d2y over dx2 minus x times dy by dx plus p squared y is equal to 0. So this way, people, we can take that answer, right? This way we can take this answer, right? Right. Question number 45 and 46, people, you can do as homework. Right. We will take now question number 47 as the next one. Take question number 47. Take question number 47. Question number 47. Question number 47, people. That's also a parametric differentiation. The same method we have to apply. But finally asking the value of the second derivative at theta equals pi by 2. Method is this, people. Using the same method, we find the second derivative d2y over dx2. The terms of the second derivative will be contained in theta. Since asking the second derivative value at theta equals pi by 2, all the theta we put part pi by 2 on the right hand side of second derivative. Then we get this answer. Right. People now try this one. Try this one. Let's see how to take this 47. Okay. What someone says this x equals 3 times 1 minus cos theta, y a times theta plus sin theta. Right? Right. People here, a is a constant, theta is a parameter. Then first we can differentiate this x with respect to theta. How to do that? This and this when we consider a constant times a function. That occasion, you know, we have to keep this constant as the same, and that should be multiplied by the derivative of the function next. Then the function, when you very carefully look at, people, it contains first the constant, it is alone. Therefore, the derivative is 0 minus cos theta. Derivative of cos is, people, minus sin theta. This time we differentiate this cos theta with respect to theta. Therefore, this is differentiable. Now, there we can write, people, the dx by d theta as, right, minus minus plus a sin theta. Right. Now come to this dy divided by d theta. A is a constant, keep as the same. This time, this theta, we have differentiate theta. It's 1, no? We have differentiate x with respect to x is 1, like that theta with respect to theta is 1. Sin theta derivative with respect to theta is cos theta. This is what we get. Now we have to apply, people, by chain rule. By chain rule, we can write by chain rule. We can write dy by dx is equal to dy by d theta into d theta by dx. Right. Substitute for dy by d theta. It is this, no? Right. Dy by dx is equal to dy by d theta a times 1 plus cos theta. D theta by dx means, people, take reciprocal 1 upon a sin theta. This a and this you can cancel down. Then we get dy by dx as 1 plus cos theta divided by sin theta. Right? Okay. Dy by dx is okay, people, now. Now we need the second derivative. Right? Second derivative. Okay. Now this time we are not asked to develop, people, differential equation. So therefore, second derivative we need to find. Now this time I am not going to use the cross multiplication. I write it like this, dy by dx, and this cos theta, I write people like this, 2 cos squared theta by 2 minus 1. People, you know, we have half angle formulae for cos A. One half angle formula for cos A we have 2 cos squared A by 2 minus 1. And that one I wrote for this cos theta. 2 cos squared theta by 2 minus 1. The sin theta, people, I can write by using the half angle formula. What? 2 sin theta by 2 into cos theta by 2. This way. Right? Then 1 and this minus 1 you can cancel down. Then we have dy by dx this way. 2 cos squared theta by 2 divided by 2 sin theta by 2 into cos theta by 2. This 2 and this 2 you can cancel down. This cos theta by 2 we can cancel down with this 1 cos theta by 2 of this cos squared theta by 2. Now what do you have? Dy by dx is, people, cos theta divided by 2 divided by sin theta divided by 2. Cos by sin is cot theta by 2. Here we get cot theta by 2 we get. Understood? Right. We get cot theta by 2. Once you use the cross multiplication, people, you get the answer correctly, but it will be creating another differential equation involving first derivative and second derivative. But we need to find in this case only the second derivative. No, that's why we don't use the cross multiplication. Right? Though you use the cross multiplication and differentiate, you get, but not only the second derivative d2y over dx2 we get to the left hand side. In addition to that, first derivative also come in. Then we can again find that. In this case, this is easier. I told the cross multiplication you have to use whenever you need to develop differential equations. This time we are not asked to develop a differential equation. We need to find the second derivative value at theta pi by 2. So now only we have to differentiate this. Now we differentiate again both sides with respect to what, people? X. Then we apply the differential operator d upon dx like this. Right? This is dy by dx. We differentiate again. What do you get? d2y over dx2. Right. Now here we have theta, but that should be differentiated with respect to x. We can't. We have to have here theta, because this letter only we must have here to differentiate this. Then here we apply chain rule, right? This place of dx we write as d theta. And this must be multiplied by d theta by dx. d theta by dx. Tell me how to differentiate cot. We have differentiated with respect to theta. Cot theta by 2 should be differentiated with respect to theta. Derivative of cot is what, people? Derivative of cot x is what? Minus cos x squared x. Then derivative of cot theta by 2 minus cos x squared theta by 2 multiplied by derivative of theta by 2. Understand? Derivative of theta by 2 is what? Half. Correct? No? Theta by 2 you can write as half into theta. No? Half we have to keep as the same. Derivative of theta with respect to theta is 1. Right. Now come to that. d2y over dx2 is equal to cot derivative is minus cos x squared theta by 2. And now so far we have differentiated cot only. That should further be multiplied by derivative of theta by 2. Derivative of theta by 2 is half. Multiplied by half. Right. d theta by dx. Here, dx by d theta is a sine theta, then d theta by dx is 1 over a sine theta, 1 over a sine theta. Right, this all. Now we have d2y over dx2 is equal to, right, this is 2a. I can write that one like this, minus the sine 1 upon 2a. People, cosec squared theta by 2, I can write cosec squared means what? 1 over sine squared. 1 over sine squared theta by 2. This cosec means what, people? Cosec means 1 over sine, no? Then cosec squared means 1 over sine squared theta by 2 into this, people, what? Sine theta. Now we got this way. Now we are asked to find what, people? The second derivative value at theta pi by 2. Now what we do? The second derivative value at theta pi by 2 that we express as a symbol notation, people. We write the second derivative, we close that by a bracket, and here we write theta pi by 2. Theta pi by 2. Put that theta pi by 2 here and here. Then what do we get? Minus 1 over 2a. 1 over sine squared. Theta is pi by 2. Once you put pi by 2 here, pi by 2 divided by 2 means pi by 4. Sine squared pi by 4. Into 1 over sine pi by 4. Sine pi by 2, no? Theta is pi by 2, no? For theta, we substitute pi by 2. Now simplify this furthermore. Right, on the right hand side, minus 1 over 2a. Sine pi by 4. Sine pi by 4 means 1 over root 2. Sine 45, 1 over root 2, no? It's perfect squared only here we have. 1 over root 2 perfect squared means 1/2. So therefore, 1 upon 1/2 here. Sine pi by 2 is 1. This and this you can cancel down. Then we get minus 1 upon a is the second derivative value at theta pi by 2. This is how, people, we take that answer. Right. Right, people, now we'll come to another one question from this kind. Right. That is the question number 48. Take question number 48, people, as the next question. Question number 48. Take question number 48 as your next question, people. That also asking to find second derivative value at t equals pi by 6. 48 question, right? X equals a times 1 minus cos cube t y equals a sine cube t, right? Asking the second derivative value at t pi by 6, right? Try this question, people. Good, right, good, right. Now we differentiate this dx over dt now. Keep this a as the same. 1 is a constant 0. First we have differentiate this power, no? 3 comes before 3 cos squared t, and now this should be multiplied by the derivative of cos t. What is that? Minus sine t. Yeah. So now when you differentiate, when you write this one, people simplify a little more. What do you get? Minus plus 3a, no? 3a. It is cos squared t sine t. Okay. Right, now come to this. Y equals a sine cube t. Then we get dy by dt. A is a constant. Start from this 3 sine squared t. Sine to 0 is cos t. Right. Now apply chain rule by chain rule, right? By chain rule, we can write dy by dx is equal to dy by dt times dt by dx. Dy by dx comes now, right? Dy by dt, it is this 3a sine square t cos t. 3a sine square t cos t. dt by dx is, people, the reciprocal of this 1 over 3a cos square t sine t. Right. Now this 3a you can cancel on with this. 1 cos t you can cancel with this square. This sine t you can cancel out with this sine square t. Right. Then we get dy by dx. We have what, people? Sine t divided by cos t. It is tan t. Right. Okay. Now we have to differentiate both sides with respect to x again. Right. And then we get d over dx, dy by dx left hand side. Equals d over dx tan t. This is the second derivative. d2y over dx2 equals, here apply what? Chain rule. T here, tan t dt by dx. Okay, like this. This is second derivative. We have to differentiate applying chain rule here. Tan t derivative is, people, sec square t. dt upon dx is this answer, right? Reciprocal of this. Now put that there. d2y over dx2 is therefore, this is sec square t, sec square t, dt upon dx is, people, 1 over 3a cos square t into sine t. You know, people, sec squared means 1 over cos squared, no? Then d2y over dx2 is therefore 1 upon cos squared. That cos squared and this cos squared, cos to the power 4. Then this 3a also there, no? 1 over 3a cos to the power 4t into sine t. Correct, no? This time asking to find the second derivative at t equals pi by 6. Put here d2 y over dx2. We need this value at t equals pi by 6. Now substitute on the right hand side every t. Right. Pi by 6. Cos to the power 4t means cos t to the power 4, no? T is pi by 6. Is to the power 4. And sine pi by 6. It is 1 over 3a cos pi by 6, cos 30. Cos 30 root 3 by 2. then root 3 by 2 to the power 4. Sine pi by 6 is half. Sine 30 is half, no? Yeah. How to simplify here? Root 3 to the power 4 means 9. Here 2 to the power 4. And this 2. 2 to the power 4 come in here, no? That 2 to the power 4 and this 2 means 2 to the power 5. That goes to numerator. Then we get 2 to the power 5 come into the numerator. Here people, root 3 to the power 4 means 9. 9 into 3 is 27. But 2 to the power 5 is 32. 32. 32 divided by 27. All right. So this is how people we take the next answer. Yeah. Now your tutorial. You can now do people the questions up to the question number 76. Up to question number 76, all the questions now you can do. This is the end of all the theories, right? This is the end of all the theories. Next day we start people the application of derivatives. Next day we start the application of derivatives.